Welcome viewers. In this video, we will see the relation between electric potential and electric field intensity. Electric potential V and electric field intensity E, followed by some problems. First, we will see the relation between E and V, electric field intensity and potential V. Let us consider this diagram. So, the point charge is placed at the origin. So, charge Q is placed at the origin. The point P is located at a distance r meter. Here one point P is located at a distance r meter. This is the unit vector. AR is the unit vector. So this is the electric field intensity. Due to the charge at point P, the electric field intensity is created. Right? So the charge is placed at the origin. Point P is located at a distance r meter. AR is the unit vector. E is the electric field intensity at point P due to the charge Q. I will see the formula for this. So E equal to Q divided by 4 pi epsilon r square into AR cap. Electric field intensity is a general formula. Q divided by 4 pi epsilon r square. But we know that the del of 1 by r equal to minus 1 by r square into AR. The del operator. What is the del operator? It is a partial differentiation. Dou by dou x, dou by dou y, or dou by dou z. In case of r, it is dou by dou r, dou by dou pi, dou by dou theta, like that. Here only r is there. So by differentiating 1 by r is nothing but minus 1 by r square. So in this 1 by r square available here can be replaced by del of 1 by r. Okay. So from this relation, what we got? Del 1 by r equal to minus 1 by r square. See this in this expression E. Q divided by 4 pi epsilon r square. So 1 by r square. This 1 by r square is replaced by this value. Del of 1 by r with negative. So that is given here. Q divided by 4 pi epsilon. Right. 1 divided by this 1 by r square. Now replaced by del of 1 by r. So by simplifying we can write minus del Q divided by 4 pi epsilon r. What is Q divided by 4 pi epsilon r? That is nothing but potential V. Right? So now we can replace this as a V. So that E equal to minus del V. So finally what we got? Electric field intensity equal to minus del V. What is the meaning for this? The electric field is a negative potential gradient. Electric field and potential are negative gradient. This equation indicates the direction of electric field is opposite to the direction of rise of potential. Right? Both are negative gradient. The rise in electric field intensity is opposite to the rise of potential. E equal to minus del V. So by using this relation, we'll see a few problems. We'll see the first problem. The first problem is determine the electric field intensity. We need to find the electric field intensity E and unit vector for the point at a point 1, 1, minus 1. In the field of potential is given by V equal to 2x square y cube z. So in this problem we need to find electric field intensity and unit vector. The potential is given. The potential equation is given 2x square y cube z and point also given 1, 1, minus 1. So from V we need to find the E value, expression for E. So we know that the relation is available. E equal to minus del V. So by using this relation we can find the electric field intensity from potential. What is del V? The V is nothing but 2x square y cube z. The value of V is given in the problem. What is del operator? I already told is a partial differentiation. Dou by dou x into Ax vector, dou by dou y into Ay vector plus dou by dou z Az vector. Partial differentiation with x, y and z. Now multiply this value dou by dou x of 2x square y cube z into Ax vector, dou by dou y of 2x square y cube z into ay vector and dou by dou z of 2x square y cube z into az vector. So what is the meaning? This one we need to differentiate with respect to x. That is remaining terms are constant. Y and z are constant. What is the meaning of dou by dou y? We have to differentiate with respect to y. X and z is constant. Dou by dou z means we need to differentiate with respect to z. X and y are constant. Right? So while differentiating, what we are getting? Dou by dou s. So the x square. Differentiation of x square is 2x. Already one 2 is there, so that it is 4x y cube z. Right? This y cube z is written as it is. X square is the differentiation of x square is 2x. Already one 2 is there, so it becomes 4x. Then this one differentiation with respect to y. Right? So differentiation with respect to y cube. Differentiation of y cube is 3y square. Differentiation of y cube is 3y square. 3, already here 2 is there. 2 into 3, 6. 6x square y square z into ay vector. Right. Then differentiation with respect to z. Here z is available. So differentiation of z is 1. So only we have 2x square y cube into az vector. Right. So here we are differentiated with respect to x. That is 2x means x square means 2x. Y cube means 3y square. Z means 1. Now we got the relation. Now we got the expression for E. Now the point is given 1 comma 1 comma minus 1. So that we can substitute this point so that we'll get the unit vector. E at 1 comma 1 comma minus 1. That is we need to substitute x as 1, y equal to 1 and z equal to minus 1. Right? So 4 into x is 1. Then y cube, 1 cube. Z is minus 1 into ax. Similarly 6 x square is 1. Y square 1. Z minus 1. Into 2 into x square y cube. Here z is not available. Right? Only here and here z is available. Here z is not available. So that due to negative, what we are getting? Already one negative available outside. Minus 4x minus 6ay. Here there is no negative, so it is plus 2az. Right? So minus of minus 4ax minus 6ay plus 2az. Now multiply this negative inside. So these two become positive. 4ax vector plus 6ay vector minus 2az vector. Because of positive, it becomes negative. What is unit vector? Unit vector is nothing but vector by scalar. The formula for unit vector is r vector by r, modulus of r. So the r vector is 4ax vector plus 6ay vector minus 2az vector. What is the magnitude? Square root of this? All these terms should be squared. 4 square plus 6 square plus minus 2 square. So that is equal to 56. So the unit vector will be 4ax vector plus 6ay vector minus 2az vector divided by square root of 56. So this is the unit vector. So this is nothing but electric field intensity. We calculated from the potential. This is the first answer, electric field intensity. After substituting the point, we got unit vector, this value. So in the second problem, we'll see that two identical spherical charges are available. Conducting sphere having a charges of 2 into 10 to the power minus 9 coulomb and minus 0.5 into 10 to the power minus 9 coulomb. Two charges in a spherical form is available. One value is 2 into 10 to the power minus 9 coulomb. Another is 0.5 into 10 to the power minus 9 coulomb. It is placed at a distance 4 centimeter. We need to find what is the force between them if they are brought into contact and separated by 4 centimeter. Right? Both are brought into contact, mixed together. Again it is separated by 4 centimeter. In both the cases, we need to find what is the force between them. Before brought into contact, after brought into contact, what is the force between them? That is the question, right? So this is a Q1 value, this is a Q2 value. The distance between is 4 centimeter. Right? So the given data, this is Q1, Q2 and R value. So before brought into contact, first we will find the value. The two charges before brought into contact. So we can take this value as it is. Q1 is 2 into 10 to the power minus 7. Q2 is 0.5 minus 0.5 into 10 to the power minus 7. Right? The formula is 9 into 10 to the power 9. It's a scalar, not a vector. 9 into 10 to the power 9 Q1 Q2 divided by R square. So 9 into 10 to the power 9 is Q1 value. 2 into 10 to the power minus 9 Q2 value minus 0.5 into 10 to the power minus 9 divided by 4 centimeter. So that it is 4 into 10 to the power minus 2 converting into meter. So what we got? Minus 5.625 into 10 to the power minus 6 Newton. So before brought into contact, as a normal condition, these two charges as it is, by using this value we calculated the forces minus 5.625 into 10 to the power minus 6 Newton. Right. Now the charges are brought into contact. Both are added together. Q equal to Q1 plus Q2. We added both the charges. So 2 into 10 to the power minus 9 minus 0.5 into 10 to the power minus 9. So what is the value? 2 here, that minus 0.5 there. So it is 1.5 into 10 to the power minus 9 Coulomb. So while adding both the charges, what we got? 1.9 into 10 to the power minus 9 Coulomb. Now again it is separated, brought into contact. Again it is separated into two parts. That also placed at 4 centimeter. What will happen if it is separated? The charges will be splitted into two equal parts. That is the important thing. This is the one value 2. Another charge is minus 0.5. Both are added together. What we got? 1.5. But while splitting, the nature of the charge is it will split into two equal parts. Right? That is the one nature, one property of the charge. Charge will be splitted into two equal parts. So that Q1 and Q2 equal to half of this value. 1.5 is 1.5 into 10 to the power minus 2 divided by 2 means 0.75 into 10 to the power minus 9 Coulomb. It is splitted into exactly half. 0.75 minus 9 into 10 to the power minus 9 Coulomb. Now both Q1 Q2 are same value. So by using this value, we can find the force again. Right? The same formula, 9 into 10 to the power 9, this is Q1 and Q2, both are equal, divided by the distance. So what we got? 3.164 into 10 to the power minus 6 Newton. Right? So the first condition what we calculated without normal case, without brought into contact. After brought into contact, both are mixed together. The important point is while splitting, it will split into two equal parts. Exactly half of the charge will be splitted, right? So the 1.5 means while splitting into 2, it will be 0.75 into 10 to the power minus 9 Coulomb. Both Q1 and Q2 will be same value, splitted into equal parts, right? By using this charge, we calculated the forces 3.164 into 10 to the power minus 6 Newton. Now we'll see the third problem. 3 equal positive charges. The value is 4 into 10 to the power minus 9. Each are located at 3 corners of the square of side 20 centimeter. Right? The one square is available with the side 20 centimeter. At the 3 corners, this 4 into 10 to the power minus 9 Coulomb charge is placed. All 3 corners are equal value. Now our question is determine the magnitude and direction of electric field at the back end corner of the square. The 3 corners, the charges are placed. One more corner is there. At that corner, we need to find what is the electric field intensity, magnitude as well as direction. So this is the given problem. We will see the diagram. So this is a square with 20 centimeter. Right? R equal to 20 centimeter. That is 20 into 10 to the power minus 2. That is 0.2 meter. right? It's a square with 0.2 meter, so 0.2 is given. These three corners the charges are placed. We will assume that Q1, Q2, Q3. These three corners the charges are placed. What is the value of the charge? 4 into 10 to the power minus 9 coulomb. The charge value is equal. All three corners having equal amount of charge. Our aim is the remaining corner is available. We need to find, the question is, we need to find the electric field intensity at the fourth corner due to this Q1, Q2 and Q3, right? So that is nothing but we will take it as this E2. We will see one by one. So at this corner we need to find the electric field intensity. First consider Q1. So the electric field intensity due to Q1 will be E1 in this direction. Both are available in the same line. So only one component E1, right? So the E1 is the electric field intensity on point P due to the charge Q1. Due to both are placed in the same line, only we have the E1, only horizontal component. Now consider Q3. Q3, due to Q3, the electric field intensity available in point P is E3. These two also available in the same line, so we have only one component. E3 is a vertical component, right? So E1 is the electric field intensity due to Q1. E3 is the electric field intensity at point P due to Q3. So these are all available in the same line. But we'll consider in Q2, this corner, the electric field intensity is E2 at this point P, but it is available at an angle of 45 degree. It is located at an angle of 45 degree. But Q1 and Q2 placed at the same line. There is no horizontal or vertical component. But these two are, this point and this point is placed at a distance at the angle of 45 degree. So that this E2 is split into two components, vertical component and horizontal component, EV, EH. The sum of EV and EH equal to E2, right? So now what are the components we have? E1 is available, E3 is available, EV is available, EH is available. This E1 and EH, these two are horizontal component. E3 and EV, these two are vertical components. Like that we can find, easily we can able to find. So we will find E1, E3, EV and EH. So by adding all, we will get the total electric field intensity at point P due to Q1, Q2 and Q3. Right? So first we will consider the charge Q1. It is very simple. E equal to Q divided by 4 pi epsilon R square. That is the formula. This is a unit vector. Right? Because the Q1 located in the same line. So there is no other component, only we have E1 only. So E1 equal to Q divided by 4 pi epsilon R square. Q is 4 into 10 to the power minus 9 divided by 4 into pi into epsilon naught is 8.854 into 10 to the power minus 12. It is, we consider as a air medium. So the epsilon R equal to 1. And R value is 0.2. This 0.2 is available. 0.2 square. So what we got? E1 equal to 900 AX, voltage per meter, right? 900. So while considering Q1, the E1 value will be 900. Only one component. Now consider Q2. While considering Q2, what is the thing? We have horizontal component as well as vertical component. Horizontal component is in general total component multiplied by cos of theta. Vertical component equal to total component multiplied by sin of theta. Here theta is 45 degree. It's a general formula. Horizontal component equal to total component multiplied by cos 45. Vertical component equal to total component multiplied by sin 45. Now what is this R value? We need this R value. That is the important thing. From the diagram, see this, the distance between point P and Q1 is 0.2. Distance between point P and Q3 also 0.2. But distance between Q2 and point P is not known. We need to find from Pythagoras theorem, because these two values are known, 0.2, 0.2. So according to Pythagoras theorem, this value, let us consider r equal to square root of r square equal to 0.2 square plus 0.2 square. So we need this distance. This distance can be calculated using this Pythagoras theorem, right? R equal to square root of 0.2 square plus 0.2 square. So finally what we got? Square root of 0.08, that is nothing but 0.2828 meter, right? So what we need is, this distance is needed, that is 0.2828 meter, that is calculated from the Pythagoras theorem, right? Now we need to find what is the horizontal component and vertical component. Now we got the value of r. So while considering the second charge, E2 is the vector sum of horizontal component plus vertical component. Horizontal component is E2 cos 45 into AX vector plus E2 sin 45 into AY vector. This is horizontal component, this will be vertical component. You take the E2 outside, so we have cos 45 AX plus sin 45 AY. What is E? Q divided by 4 pi epsilon r square. So this r is already we calculated based on the Pythagoras theorem, into cos 45 AX plus sin 45 AY. Right. Now we'll substitute the value. The Q is 4 into 10 to the power minus 9. This cos 45 is 1 by root 2 into AX. Sin 45 also 1 by root 2 into AY. Now A in 4 into pi into epsilon is epsilon naught, 8.854 into 10 to the power minus 12 into r. R value we calculated 0.2828 square, right? So by simplifying this, what we got? 450. By multiplying inside, what we got? 320 AX plus 320 AY, right? So while considering the second charge, we have horizontal and vertical component. So that is given as 320 AX plus 320 AY, right? Now we'll go to the third charge. Third charge, again it is same, because there is the charge value and distance is already equal. So the E3 is equal to E1. E1 we already calculated 900 AX. So E3 also 900 AY. Only it is available as a vertical. So that no need to calculate again. The already calculated E1 value taken as E3. Both E1 and E3 are same. Only E1 is the horizontal component, E3 will be vertical component. Now we got all three values due to Q1, Q2, Q3. So that can be added together. So E equal to E1 plus E2 plus E3. So the E1 equal to 900 into AX, horizontal. E2 having two values, horizontal component and vertical component. Just now we calculated. And E3 900 AY. These two are equal. This is horizontal, this is vertical. Now we can add all, so that 1220 AX plus 1220 AY, right? So by taking the modulus, what we got? 1725.3 voltage per meter. So the electric field intensity at the fourth corner, due to the remaining three corners, Q1, Q2, Q3 will be this value, 1725.3 volt per meter.